Alright, today we're going to look at how to do some problems involving Half-Life. These are pretty easy if you understand what's going on, pretty hard if you don't. It's like a lot of things. So, first start out with the definition. The half-life is the time required for half of a radioactive sample to decay. I believe at the time you see this you will have already done the penny lab, so we're talking about each time that you shook the container would be like a half-life. And so every time you shake the container, a half-life passes. Except now we're not shaking anything, we're just kind of waiting for time to pass. And after a certain amount of time, the half-life, it's going to decay, half of it's going to go away. And so that's the basic definition. To kind of see what we're talking about as an example, imagine, if you will, that we have a 50-gram sample of undecayed stuff and that it has a half-life of 20 years. If we sit around and wait for 20 years, we will see that half of it will have gone away. Half of it will have decayed, turned into something else, while the other half will remain undecayed. And so it goes from 50 grams to 25 grams in one half-life, which is 20 years in this example. So after an additional 20 years, it doesn't all go away. Half of what was remaining goes away, and you're left with this. So now instead of 25 grams, you have 12 and a half. So after a total of 40 years, 20 plus 20, you now have 12 and a half grams. And then if we keep going another half-life or another 20 years, half of those 12 and a half will go away, and you'll be left with 6.25 grams. So on net here, we would see that after 60 years, which is 3 half-lives, it goes from having 50 grams down all the way to 6.25 grams. And so that's kind of an example of how this would work. On a problem on a homework or a test, it would look something like this. How much of a 420 gram sample would remain after 50 years if the half-life were 10 years? And so you can pretty much just kind of figure this out. There's shorter ways, but we'll just go with the simplest. So 420 grams is what we start with. And so we're going to go 50 years. But you can't go all 50 at once. You got to go one step at a time. So after one half-life, after 10 years, you're going to cut it in half, because that's what happens in a half-life. You're going to be left with 210 grams. And then after 10 more years, you're going to be left with half of 210, which is 105 grams. And then after 10 more years, it's going to go down to 52 and a half. And then after 10 more years, you're going to be down to 26 and a quarter. I just notice that I'm just cutting it in half every time. Now if we stop and count, we've gone 10, 20, 30, 40 years, so we only have one more to go, one more group of 10 years, one more half-life to go, and that will cut it down to half of 26.25, which is 13.125 years. Or grams, I'm sorry. So the answer to the question is, after 50 years, that's gone through 5 half-lives, it will cut itself in half 5 times, leaving you with 13.12 grams. Now a different way that you could ask a similar question is to go the other way. Rather than ask how much is left, you could tell how much is left and figure out how long it's been. So here we're told that we have a 120 gram sample, but only 15 grams remains. So the question then is, how many half-lives has passed, which is really simple. All it's doing is it's saying, it's a fancy way of saying how many times has it cut in half. How many times did it cut in half? How many half-lives did it go through? So we would say, okay, Well, we went from 120 to 15. Well, 120 cut in half is 60. Didn't get us there. So let's cut it in half again. That gets us to 30. And so that didn't get us there. Cut it in half again. That gets us to 15, our magic number. That's what we're looking for. So apparently it took 1, 2, 3 cutting in half, which is to say 3 half-lives. And so that's how all these problems work. You're just going to be told one thing about what you start with or what you end, and figure out what it is that they're asking. The last example we'll do real quick here involves a sample that originally contained 500, but now it has 31.25 grams after 12 years. What is its half-life? So this time we're not being told the half-life, we're being told what happens. We're told that you start with 500 and you end with 31.25, and that process takes 12 years. It doesn't say that the half-life is 12 years, it says that this happens in 12 years. It's obviously gone through more than one half-life because it's been cut by more than a half. So let's figure this out by first just finding out how many times it's cut itself in half. So if we cut 500 in half, the original sample, we now have 250. That's after one half-life. After 2 half-lives, we're going to have 125. After 3 half-lives, we're going to have 62.5. And after 4 half-lives, we're going to end up with 31.25. That's our magic number. That's what we're starting, that's what we're ending with. So we know it's taken 1, 2, 3, 4 half-lives. So the answer is it took 4 half-lives, but that's not the question this time. That was our question last time. This time the question is, what is its half-life? Well, we know that 4 half-lives took 12 years. So 12 years for 4 half-lives. So if you divide 12 by 4, you will get 3 years per half-life. In other words, the half-life is 3 years. And that's how you do those.